Hello and welcome all on Unacademy JEE English, guys. And today I am going to take lecture number 4 in your rapid revision. And guys, today I am going to start periodic table. And in periodic table, guys, yes, I am going to cover. Today I will take just a minute. Just a minute. Today I am going to take. Today I am going to take this one. Periodic table and periodicity in properties, and during this, guys, I'm going to take this periodic table, modern periodic table, and what are advantages of that. So we will be covering all these topics today. Prior to this, I have already covered quantum number and electronic configuration. So hello, welcome, and good afternoon everyone, right? So I hope now you got it. Now you got it. So let's see now. Hello Monica, hello Kaushik Jain, hello everyone. So guys, are you ready for today's session? So let's begin it. And before starting it, guys, let me introduce you guys. Yes, I'm Rahul Kaushik and I worked in Bansa Classes Kota, guys. I worked in Bansa Classes Kota for continuous 10 years. And during my tenure there, I was head of department. I was head of department in Bansa Classes Kota. And guys, I mentored 2000 plus IITs. Okay. I mentored 2000 plus IITians there. And after that, I co-founded my own organization. That is Igyan Education Private Limited. And now, along with all my experience and knowledge, I'm here on Unacademy, India's largest and fastest growing online platform. Okay, guys. So now I will tell you the simple steps how you can subscribe to Unacademy. Just go to Play Store or down and download Unacademy's learning app. And after downloading it, guys, install it. And after installing it, just click on the plus. So once you are clicking on the plus, you will be directed to this page. And on this page, guys, you have to choose your goal. Suppose you are preparing for IIT JEE, then it will be IIT JEE, and then you have to hit the subscription button. Okay, guys. After hitting the subscription button, you have to choose either for 12-month program or for 24-month program. And guys, here comes the financial problem. So let me tell you, for 1 year the fees is 38,000. For 2 years the fees is 56,000. But don't worry, if you are applying my code, that is Rahul Kem, in that case you don't have to pay 38. Instead you have to pay 34,650 rupees. And instead of 56k you have to pay 50k. Okay, guys. So this is the fee structure. And you people will pay if you are applying Rahul Kem. So guys, remember this code, it will help you in getting that discount, right? So now what are the benefits of plus? So guys, on the plus you will be having structured course, there would be live quizzes, and after every third class, means I can say every fourth class will be doubt clearing session, and then you will be having their mega quizzes after completion of course. And then guys, you will have access to the iconic test series conducted by Unacademy. So these are all the benefits which you people will get. Okay, guys. Okay, and don't worry, thermodynamic I will be starting in the 11th, so don't worry, surely I will be starting that. Currently chemical bonding is going on, so just work on that. Okay, so just remember this code, guys, Rahul Kem, just remember it, and then if you are remembering it, then you will be eligible to get the flat 10% discount. Okay, guys. So now let's start now. So this is the lecture number 4, periodic table and periodicity in properties. Okay, guys. So I will be quick because this is rapid revision course, so I have to be quick here. So get ready with your lecture notes, with your copies and everything, guys. Okay. So during this, yes, I will be telling you each and every point, but I will be quick. So guys, first of all, what is the importance of arrangement? What is the importance of arrangement? Can you see something on this screen? On this screen, guys, we have books. On this screen, guys, we have books, and they are randomly arranged. So suppose in a library there are 10,000 books and they are randomly arranged, and you want to find out a particular book, it would be difficult. It would be difficult, right? So now let's have a look on another picture. So this is the picture of library, guys. This is the picture of library, right? Hello, Priya. So when we are talking about this library, guys, when we are talking about this library, here everything is arranged. And in library, you might have seen, guys, like here we have, here we have, suppose this is your science section, right? This is your history section. So if you are arranging those books in this way, then you can easily find. Suppose you are looking for some history books, then you don't have to look it for in the science section. And if you are looking for history, then you don't have to look in the science section, and if you are looking for science, then you don't have to look in the history section. So arrangement is very important, and if there is systematic arrangement, then that will help you in many ways, right? So why we are discussing it, guys? So what is periodic table? Because when we are talking about the periodic table, let me tell you, almost now there are, yes, if I'm talking about the periodic table, so now there are 100 plus, actually 118, but all elements are not found in abundance. So there are 100 plus elements, right? And means, okay, now let me write 118 elements. And each and everything which you can feel or observe around you, everything is consist of those elements, right? Everything. So if we want to arrange those 100 elements and we want to analyze them, then it becomes important that we arrange them in a proper order, where we can arrange them like element with similar property can be in one pocket, element with similar property but different from the first group, we can place them in another. So guys, we need periodic table to arrange those 118 elements, so that analysis of their properties or many things becomes easier, right guys? That becomes easier. So what we are doing here, guys? So in periodic table, what is periodic table? So guys, this is periodic, this is tabular arrangement. Just a minute. This is tabular arrangement of various elements according to their properties. So what is periodic table, guys? It is tabular arrangement of various elements according to their properties. Got it? Good afternoon, everyone. So next point, guys, why do we need to classify the elements? So what are the points? So guys, at present there are 118 elements. Of them, the recently discovered are man-made. I told you that almost 80 to 90 elements are found in proper abundance. Otherwise, most of the elements after 90 are made in laboratories, and they are in very less amount, trace amount. With such a large number of elements, it becomes difficult to study them individually, right? If in a class we have 100 students, then it would be difficult to classify each and every student by his name and by his characteristics. But what can we do? Like suppose somebody is scoring 90% plus, so I can make them sit in one row. And suppose somebody is performing between 80 to 90%, then second row and third row onward. So I can directly say that this row consists of these students and these are having proper percentage. Similarly, if with such a large number of elements, it is very difficult to study them individually. So what we do, to ease out this problem, scientists search for a systematic way to organize the elements so that we can classify them. Okay, now guys, it would rationalize known element fact about the element, but even predict new ones. So by properly systematically arranging them, you can analyze them and you can also predict about the future elements. Okay guys, so when we are talking about it, let's talk about the development of periodic table. So currently we talk only about the modern periodic table, but guys, let me tell you here that before modern periodic table, yes, there were many scientists who made periodic table, and then there were disadvantages and those were rejected, and finally Lavoisier, Daubernier, Newland, Lothermeyer, Mendley, Moseley, modified, and now we are modern periodic table. We are here, right? But before that, there were so many changes. So there were many scientists who were preparing the periodic tables, and in JEE Mains or in JEE Advanced, not JEE Mains. Let me tell you guys, in September attempt, there were 10 to 12 questions from periodic table itself. Okay, guys. So just revise it properly. Yes, Sivayati, it is compact course. I will be teaching you each and every concept, but very fast. Okay. So now these were the attempts made by the scientists. So let's go for the first one. What is Lavoisier? So initially the Lavoisier classified the element like in proper in two modes. He said metals are either elements are either metals or non-metals. So he told us about the properties of metals. You know, they are sonorous, they are lustrous, they are hard but not brittle, good conductor of heat. They are soft but brittle, they are bad conductor of heat. No such properties observed, no such properties observed. Sonorous and lustrous, these properties are not found in the non-metals. Got it, guys? So now if I move to the next point, guys, yes, then came the Daubernier triad. And what Daubernier said? He observed that certain element when arranged in group of three element in a way that atomic mass of middle one is arithmetic mean of the third one, then their properties are similar. So they were just trying some combinations. Suppose you are arranging three elements A, B and C, right? So according to this theory, that atomic mass of B will be sum of atomic mass of A plus C by 2. Arithmetic mean. You know how to calculate arithmetic mean. Okay, guys. So this is how they did. Suppose I am arranging lithium, sodium and potassium. So if you are adding 7 and 37, 7 and 39 and divide that by 2, you will be getting 23. Similarly, if you are adding these two and divide it by 2, you will get strontium. So he arranged the elements in groups of 3 in such a way so that the middle one was having the same property, and its atomic mass was what? Arithmetic mean of other two. Hi Varun, Nitin. So just solve this problem and tell me the answer. Be fast. So such problem can be asked in JEE Mains. Be fast, guys, be fast. Tell me the answer. Everyone write your answer in the chat box. Write your answer in the chat box. Be fast. Tell me, guys. A, B, C formed over neutral. Find the mass of C. I'm not getting any answer. Hi Varun, hi Sivayati. Be fast. So what can you do here? You have A, B and C. This is 16. This is 18, and you know this X is not known. So how will you get this 18, guys? How will you get this 18? So this 18 will be 16 plus X by 2. Got it? So you will be getting it. Yes, Harvinder. Yes, Nitesh. Everyone, you are right. 20. So if you don't know anything, because many student questions are why we are teaching, why you are teaching it, why we are learning it. So guys, problem can be made on anything. Problem can be made on anything, right? So now let's move to the next problem, guys. Let's talk about the Daubernier triad and what were its drawbacks. Be fast, be quick. All of the known element could not be arranged in the form of triads. So it was not satisfying the all known element at that point of time. So for very low molar mass or for very high molar mass, the mass was not holding on, right? Next, guys, as technique improved, the measuring of atomic mass accurately, the law was unable to remain strictly valid because the many atomic masses we were considering, those were not correct. When their correct atomic mass were finally calculated, answer was not matching. So with improvement in the technique, with improvement in the technique, this failed. This failed, guys. So advantage, what were the advantage? So the only advantage of Dauvergne was that it made chemists look at the element in terms of group of element with similar chemical and physical properties. Before, because without it or before it, there was only one, that was Lavoisier arrangement, that talked about the metal and non-metal. Now scientists start thinking in like this way. Yes, we have to arrange the element as per their physical and chemical properties in such a way so that element with similar properties are placed somewhere. Got it, guys? So now do it. Be fast and tell me the answer. X, Y, Z are the three elements of Dauvergne triad, and the atomic mass of X and Z are 7 and 23. So atomic mass of Y is. Yes, what will be the answer, guys? Be fast. What will be the answer? Tell me, guys. Again, a simple problem on arithmetic mean. We have X, we have Y, and we have Z. So X we have 7, Z we have 23. So 7 plus 23 by 2. It would be 15. Got it, guys? So A will be your answer. A will be your answer. Yes. Yes, Arvinder, you are right. Right. So A will be your answer, guys. So now let's move to the next, the Mendeleev law of octave. So what he did, what was his law? Mendeleev law of octave. So octaves are there in the musical notes. We have sa, re, ga, ma, pa, dha, ni, sa. Sa again repeats. Sa, re, ga, ma, pa, dha, ni, sa. Are you getting it? So what he said, like if he is arranging, when elements are arranged in ascending order of their atomic mass, in ascending order of their atomic mass, then properties of every eighth element is similar to the first one. So if I'm writing lithium 1, 2, 3, 4, 5, 6, 7, and then the eighth element is having same property as the lithium, right? And then again 1, 2, 3, 4, 5, 6, 7, 8, then again properties of potassium will be similar to this. So when you are arranging the elements as per their atomic masses, so guys, he found, so these were purely observations, he found that properties of every eighth element is similar to the properties of first element. Okay, guys, but again this law was valid only up to 20, only up to calcium. After this it was not following. And let me tell you one more thing, it was discovered, it was proposed in 1865, and after that helium, neons, these gases were discovered, and now this element become ninth. So this law of octave failed. Got it, guys? So this law of octave failed. So drawback, it was not valid beyond calcium. So when new element like noble gases were discovered, this had no place for them. And what are the advantage of Newland law of octave? So I told you the disadvantage, but still there were some advantages. The most important contribution in the process of periodicity Newland saw in every eighth element. So people or the scientists start thinking like that way, that there is some periodicity. What do you mean by periodicity? If something repeats itself after certain interval, then it is called periodicity. Okay, guys. So scientists start thinking about the periodicity. Then we have Lothar-Meyer curve. So what is this Lothar-Meyer curve? What he did, he calculated the atomic volume and atomic mass, and he arranged them. These dots are representing the elements. And after arranging these elements, what he found? He found that peaks, peaks were occupied by peaks were occupied by alkali metals, and then descending part were occupied by what? Alkaline earth metals. So these were simple observations. So his graph was like it, and he also observed that elements present at the peaks or I can say present in the corresponding positions will have the same properties, and elements present in the descending part will have the same properties, and again in the ascending part will have the same properties. So we got it, right? We got it. So again guys, here Lothar-Meyer curve, what were his observations? Yes, note them carefully. Observation number 1, peaks of all curves were occupied by alkali metals. Descending parts were occupied by alkaline, ascending by the halogens. You can see here, yes, halogens are here on the ascending part. Halogens are here, halogens are here, right? Bottom is occupied by high melting point. So at the bottom we have high melting point, like we have silicon, like we have carbon. So bottom were occupied by. So these were purely observations. These were purely observations, guys. So what was the conclusion? That properties of element present at the corresponding points are same. So what is this corresponding point? So if peak, I'm comparing 2 peak or 3 peak, they are corresponding points, right? From one peak to just below another peak, the element form a period. So what he said, from one peak to another peak we have a period. From this peak, just a minute. So what he said, guys, let me erase it. What he said this is a period. This is a period. So he termed them as a period because after every period properties are repeating. Again, after every peak there is descending part, then after every peak there is ascending part. So we call them the periods. Okay guys, so from one peak to just below another the element form a period, right? So then it the term was Lothar-Meyer. Within the same period radius first decreases. How you can say that? Because this is the volume. Within the same period, this is the period starting from here and ending from here. So first the volume is increasing, then it is first the volume is decreasing, then it is increasing. So we can say within a peak, first the volume will decrease, right? And then it will increase. Okay guys, then it will increase. So next point was within the same period radius first decreases and then increases. Got it? So these were purely his experiments. These were purely his experiments. Got it? So now let's start, guys. So if this is done, now we have Lothar-Meyer graph. A, B, C, D, E element are there. So what can you comment about it? Yes, A, B, C, D and E. If this is a Lothar-Meyer graph. Now tell me, what will be the answer, guys? Anyone? So guys, I just told you, if you remember those observations, because many students ask, sir, why do we need to remember those observations? So how will you do it? How will you do it? Tell me. Be fast. Okay, I can see here Samarth Chaurasia. Okay, guys. So there are many species who keeps on rendering, and now many species are there who can be there on YouTube, and they generally tell about their species. So thanks Samarth for telling your species. Yes. So Harvinder is saying now the peaks are occupied by alkali metal. So yes, your answer will be, tell me, your answer will be C, right? So guys, now why I'm giving you the problems over these concepts? Actually my point is because you people think like sir, what should we means why we are learning all this? So if there is a problem like it, because all these things are there in the NCERT, and if something is in NCERT, guys, it can anytime be asked in the JEE Mains or Advanced. So you cannot leave anything or you cannot take anything for granted. Got it? So now let's move. Mendeleev periodic law. If we talk about Mendeleev periodic law, guys, so what was that law? According to him, physical and chemical properties are periodic function of atomic masses. So as per Mendeleev law, they changes at the atomic masses changes, right? Properties of element are periodic function of atomic masses. Got it? So there were 12 series and 8 groups. So what were the series, guys? Yes, these are called series. These are called series. And then we have groups 1, 2, 3, 4, 5, 6, 7, 8. So this was Mendeleev periodic table proposed in 1869. And guys, I told you that yes, even till this point, inert gases were not discovered. Inert gases were not discovered. So if somebody might ask you that how many series were there, how many groups were there in Mendeleev's initial periodic table. So I'm telling you guys, this is the original periodic table. He once suggested that two elements are missing, and he even predicted their atomic masses, right? And their properties, like they will form the compound like these. So guys, when they were discovered, their properties and masses were almost similar, right? Any doubt? So now I'm talking about this. Here what he did, atomic mass of this is 127.6 and atomic mass of this is 126.9, right? So ideally, as per atomic mass, iodine should be here and tellurium should be here, but he put iodine there. So he even neglected the atomic mass for properties, because ultimately he wanted to arrange the elements as per their properties. Got it? As per their properties. Any doubt? So now let's move. We have some important point. He fully recognized the importance of properties while classifying the element, guys. He changed some elements. He placed aluminium below boron and silicon below carbon. Yes. And guys, similar because of their properties. And then he identified certain holes because those elements were not discovered at this point. Below aluminium and silicon. So I can tell you, below aluminium there were holes, and for these holes aluminium, and he predicted them, and he made this table in 1869. Then 1875 and 1876 these elements were discovered, Ica aluminium and Ica silicon. Got it, guys? So this is not Go, actually this is GA, germanium. So this is basically GA and GE. So germanium we call it Ica silicon, and gallium we call it Ica aluminium. Their properties were found as predicted by Mendeleev. Helium and argon were discovered in 1890. Got it, guys? Any doubt? So now let's move, guys. Mendeleev periodic table. Now you know this is GA and this is GE. We call it Ica aluminium, we call it Ica selenium, and their properties were found as predicted by Mendeleev. Helium and argon were discovered in 1890. Got it? So now again, this was the original periodic table given by Mendeleev. Now I have already told you the clearer version of it. Okay, guys. So Mendeleev made some corrections. He helped in correction of certain masses, like in case of you can say initial atomic mass of boron was supposed to be 13.65, but it was exactly 9.1. So Mendeleev made some corrections in this. Okay. Then came the Moseley's law. So what Moseley did, actually before Moseley everybody was attaching hello others. So everybody was saying that properties are periodic function of atomic mass. Properties are periodic function of atomic mass. But Moseley performed an experiment and he connected the frequency with the position of element. He performed some experiment which is currently beyond your scope. So, and he told us that instead of atomic mass, we should take atomic number. And guys, even till today, the modern periodic table is based on atomic numbers, right? And then he modified the periodic table. Mendeleev's periodic table was modified, right? So I will discuss this, the modified periodic table, advantages of long form periodic table. Yes, you can go through these advantages in NCRT, all are there, guys. So I'm telling you some. The modern periodic table is based on atomic number. The table shows Y element in the same group. So why he took atomic number as the fundamental property? So guys, let me tell you here, most of the properties, currently I'm also teaching you chemical bonding. So most of the properties depend upon the valence electron. Valence electron, basically valence electron and everything depend upon the atomic number, not atomic mass. So because most of the properties depend upon the number of electrons present in the valence shell, that's why he suggested that it is better to use atomic number instead of atomic mass. And after that, guys, the periodicity is related to electronic configuration. Periodicity is related to electronic configuration and all chemical and physical properties. So I have told you this thing already. Defect, hydrogen's position is not fixed, and lanthanoid and actinoids are not accommodated in the main periodic table because they are arranged at the bottom. They are arranged at the bottom, guys. How many? Just a minute. So guys, let me show you the modern periodic table. Just a minute. Let me show you the modern periodic table. Okay, it will be there. Just a minute. Yes, actually this is the long form of periodic table. What I want to show you, but this table contains two elements here and then it is having 14 element here. Then it is having 10 here and then again 6. So actually this is called long form of periodic table. This is called long form of periodic table. So guys, why do we call it long form of periodic table? Can you tell me? So here I'm telling you guys, we have 2 plus 14, 16 plus 10, 26 plus 6, 32. So it's such a long, and there was one more problem, like these elements were, most of these elements are man-made or they are present in the trace amount. They are generally radioactive. So we generally don't study them in normal chemistry. They are studied in physics mainly. In nuclear reactor, we need uranium and all these elements. So what we did, actually we shifted this part at the bottom. We shifted this part at the bottom. So when we shifted this part at the bottom, now this periodic table is like it. Got it? So these 14 elements, and after shifting these 14 elements, yes, we have connected it with it. Got it? So now periodic table is like it, because these 14 elements, now I have placed them here and here, and I call them lanthanoids and actinoids, right? Now this table has, yes, smaller size than the previous one. You can check. So previous was very large. Now we have reduced it. So this series we called 3D series, 4D series, 5D series. We also call them transition elements. So first transition series, second transition series, and we have third transition series. Got it, guys? So first transition series, second transition series, and third transition series. And these are called lanthanoids, these are called actinoids. So you should remember from where lanthanoids start. Yes. So guys, these are the points which can be asked in any exam. like lanthanum, scandium, yttrium, lanthanum 57. So lanthanides start from 58 up to 71, and then 72 comes here. Are you getting my point? Similarly, guys, up to 89 we have actinides. So actinides start with the thorium, not with the actinium. Similarly, lanthanides start with the cerium, not with the lanthanum, right? And 92, just add 14. 89 plus 14, it would be 103, and then 104 comes here. So guys, this is the periodic table. So we have shifted the 14 element here and here, yes, up to this point, so that size of this periodic table can be reduced, right? Yes, others. Lengthened contraction I will be explaining in the next class, don't worry. Today let me tell you about the periodic table. So guys, just note it down, you can take a screenshot of it. It is going to help you, right? So there is one more point. So guys, in this periodic table we have 7 periods. So these are periods, and now I call them 18 groups, right? So this is first group, second group, third, fourth, fifth, sixth, seventh, eighth, ninth, 10 up to 18. So modern periodic table we write from 1 to 18. However, in NCERT you will find the nomenclature like 1A, 2A, 3A. Now what is this? This is 3B. Then we have 4A, 5A, 6A, 7A, 8A, 3B, 4B, 5B, 6B, 7B, and then we have 3 elements together and we collectively call them 8B. Very important point. We collectively call them AB, guys. Note it down. So when we are collectively calling it, so remember each and every point about this table. So if somebody asks you that what is the period and group of lanthanides, can you write in the chat box the period and groups of lanthanide? Yes. Period and group of lanthanides. Tell me. Anyone? Write in the chat box. Write in the chat box. Be fast. Be fast. Okay, home official. Student will learn it later on. Now do it. Yes, Harvinder is saying we have sixth period. And what is the group number? What is the group number? No, no, home official. Yes, that's why I gave you these problems. So you can do it for lanthanoids as well as for actinoids. Yes, you can do it for lanthanoids as well as for actinoids. So guys, this is the thing I wanted to tell you. The period number for lanthanoid is 6 and for actinoid it is 7. For lanthanoid it is 6. But group will be 3. Group will be 3. Got it? So let me show you guys. First group, second group, and then we have the third group. And we will consider their group as the third one. We will consider their group as the third one. So remember it, guys. That's important. And I personally think that this question can be asked anytime. This question can be asked anytime in JEE Mains or Advanced. So now let's move, guys. So period and element. So we have periods. This is first period, second period, third period, fourth period, and so on. So guys, in the first period we are having 2 elements only. In the second period we are having 8 elements. In the third period we are having 8 elements. In the fourth period we are having 2 plus 10, 12 plus 6. So guys, we are having 2 elements, sorry, 2 elements, 8 elements, 8 elements, and then 18 elements. And again in this I will be having 18 elements. And in sixth period guys, we have to count these 14 as well because they come here, sixth period. So 18 plus this 32 element and 32 element. Got it? Rohan, for inorganic it is enough. Now guys, note it down, it's very important, because after this I'm going to tell you some things about this modern periodic table, how you can use it, how you can use this modern periodic table, right? What is the application, why do we call it modern, and what are the benefits of it? I'm going to tell you each and every point. Okay guys, so these are the number of elements we have just counted in the periodic table. Okay, so guys, again, classification of element according to electronic configuration, your element can be S block, P block, D block and F block. So what are S block elements? So guys, these are the configurations, these are the configurations. I'm placing hydrogen in the middle because it was disadvantage or the drawback of the modern periodic table. So here you can see guys, we have 2s1, 3s1, 4s1, 5s1, 2s2, 3s2, 4s2, 5s2, 6s2. So what is going on? So these elements are called S block. Why? Because the last electron enters into the S orbital, right? Then we have D block element. If you see the configuration, it will be 3d1, 3d2, and then it will be 3d3 and so on. So because last electron is entering into the D subshell, so I will call them as D block element. So these are S block, these are D block, these are P block because last electron enter into the 2p1, 2p2, 2p3, right? Got it? So S block, P block, D block and these are F block because the electron is entering into the F. Yes, this is from NCERT only. You can copy it, you can read it in the NCERT. Yes, not for problems. For problems, it would be good if you go for some institute material. Okay, Rohan? Right. Yes, D block and transition elements are different. D block and transition element are different. So these are the S block, normally 1A and 2A. We call them as S block. P block, last electron enter into the P block. Their general configuration is this. Their general configuration is this. Either it can be 1s2 or it can be 2s2, 2s1. So ns1. This is general configuration. Then we have D block. The general configuration for D block is ns1 to 2, and then we have n minus 1 D 1 to 10. So these are the configurations for D block. Right guys? You can see them here. So in D block, last electron will enter into the D subshell, and these electrons will be called as valence because the n is maximum for it, right? So here let me tell you, if I'm writing 4s2 3d5, yes, tell me the valence electron and tell me the how many valence electron will be there. Yes guys, be fast, write in the chat box. So guys, after it at 3:40 p.m. I'm going to take a small quiz. Small quiz on the Unacademy's app. So get ready for that and let me see how many of you can solve that. Hi Manjul. Yes, now we are teaching on the board so that you guys can have the real classroom experience. Do it. So after this, I will be taking a small quiz on Unacademy's app, guys. Be there. So guys, just tell me the answer. How many valence electron are there? Argon, 4s to 3d5. Yes, 2. Right? And last electron, if somebody asks you the last electron, so last electron is entering D subshell. I hope now you got it. Topic will be surface chemistry. Okay. So guys, D block, now we are done. These are D block. Okay. Yes. D block and transition element, there is a minute difference between them. What is the difference? So guys, these elements which have partially filled d orbital in neutral state or any stable oxidation state are called transition elements, right? So zinc, cadmium and mercury. So zinc is having 3d10, 4d10, 5d10. So their D subshell is completely filled. So we are not going to call them D. They are D block, but these are not transition. These are not transition. Got it? So guys, these are all D block, but these three are not transition. Although you can call them D block. So any element in which last electron enter into the D, that will be called D block element. But transition element, in order to be called as transition element, their D subshell should be partially filled, whether in ground state or in their most common oxidation state. Got it, guys? So zinc, cadmium and mercury are not transition elements. Somebody was asking this question. Got it? Yes. So guys, now F block we have. These are the F block, and element after the uranium are called transuranium element. So where is the uranium? This is the uranium. So these are called transuranium elements. The actinides and lanthanides have been placed at the bottom of periodic table, and this is their general configuration. This is their general configuration. Got it? So this is compact revision program. So I will be fast. If you are facing any issues, you are free to ask. Okay, guys. They are also called inner transition element. The F block elements are also called inner transition element. Have been classified into two series, 4F and 5F. It starts from cerium to lutetium and it starts from 92. So all element will have group number 3. Right? Period will change, but group will be same for all 14 elements or 28 elements. Group number will be 3. Got it? So guys, advantage of long form of periodic table and all these in the next class. In the next class, what I'm going to cover, guys, prediction of period, group and block. Suppose somebody is saying like we found an element having 280 atomic number Z. So what will be its period number and what will be its group number? How will you predict that? So in the next class I will teach you guys, right? Then just by seeing electronic configuration you can tell about the period number, you can tell about the group number. So guys, how we are going to do it in the next class, I'm going to take that, right? For P block, S block, we can find the possible number of element in a period. Suppose if I ask you in 10th period, how many electron will be there? So how will you calculate that? Yes, guys. So today after 10 minutes, I will be taking a quiz on surface chemistry. So get ready for that. And that quiz will be on Unacademy's learning app. Okay, guys. So I'm taking all these classes on TTS. It is compact revision program, guys. TTS. Tuesday, Thursday, and Saturday. Yes, this is rapid revision. This is rapid revision in which I will be covering complete 11th and 12th. Got it? In rapid revision, I will be covering so Tuesday, Thursday, and Saturday. Got it? So periodic table, the next remaining part will be covered in the next class, guys. Okay. So there will be many problems, and let's complete today's class, guys, because I have another class. So if you really like today's class, guys, then share it and like it as much as possible, guys, and click on the bell icon so that you can get latest notification of our classes. Okay, guys, and then guys, click on the plus. Once you are clicking on the plus, choose IDJE as your goal and then hit the subscription button. And after hitting the subscription button, guys, yes, choose plan for 12 month or 24 month, and after choosing it, guys, you will be getting these options. But let me tell you, if you are applying my code, then for 1 year you have to pay, instead of 38,034, instead of 56,000, you have to pay 50,000. Got it, guys? You have to pay only this fees. Yes, it is 12th class topic. So this is for now, guys. Thank you everyone. I will meet you after 10 minutes in the quiz. Thank you, guys. Take care.